Geometry lesson 3-7. Before we were discussing how we could incorporate some of the concepts from algebra and the equations in slope-intercept form with parallel lines, and the fact that if they're parallel lines they have to have exactly the same slope. And now we're going to discuss how those lines act when the lines are perpendicular. So with perpendicular lines, slopes of perpendicular lines, in a coordinate plane, the two non-vertical lines are going to be perpendicular if the product of the two slopes is -1. Now product means multiplying, which means if you take the slope of one line and you multiply it by the slope of another line, it's going to multiply together and create -1 in order for them to be perpendicular. Another way of looking at this, in other words, they are opposites, so one's positive and one is negative, because otherwise they wouldn't multiply together to make a negative answer, reciprocals of each other. So one is this fraction, the other one's going to be flipped. They're always reciprocals of each other, and one is positive and one is negative. So as an example, say one of the lines has the slope of 4/5, which is a positive. It's going to be perpendicular to another line, a second line, that has the reciprocal of that, and it's a negative fraction. It wouldn't matter if it was -4 or -5. Just one of the numbers has to be negative. If you multiplied this, 4 times 5 is 20. 5 times -4 is -20. And positive 20 over -20 is -1. So the product of the two slopes would always equal a -1. In order for them to be perpendicular, they must be opposite reciprocals of each other. Very common mistake. People forget that they have to be opposites. Sometimes they forget that they're reciprocals, but they remember the opposite. You got to remember both. You got to remember they're opposite reciprocals. So here we have a graph with two lines on it. We have line PQ and we have line RS. And they look like maybe they're perpendicular. I don't know. We got to check and see. The question is asking us whether they actually are. In order for us to determine that, we need to know the slope. So if we find the slope for PQ, as you look at PQ, it's going down from left to right. It appears like it goes down 1. So it's going down 1, which is a negative slope of 1. And it goes to the right 1, 2, 3, 4, 5, 6, 7, 8. So it goes this way 8, which is a positive value. So for PQ, we would say the slope is -1/8. That's the slope. In order for it to be perpendicular, RS is going to have to be the reciprocal of this and positive. As I look at RS, it's definitely going up as I look at it from left to right. The question is it going up 8 and right 1? Let's check. It goes up 1, 2, 3, 4, 5, and over 1. So it's only going up +5 and right 1. Now they are opposites, because one's negative and one's positive, but they are not opposite reciprocals of each other. So from that alone, 1, 2, 3, 4, 5, and over 1, down 1, 2, 3, 4, 5, 6, 7, 8, we'd have to say no. They are not perpendicular. They're close. It's very close, but they are just off. They're not quite perpendicular. Had one of this been like -1/5, or if that was 8/1, then we would have had it. Now looking at equations without a graph. Say you have two equations, which both of these are in slope-intercept form. The question is, are these two perpendicular? In order to know that, you have to be able to realize that that's the slope. M stands for slope, as we recall from yesterday. And there's one slope, and there's the other. So some people jump to the conclusion, they say, yeah, they are. They're perpendicular because that one's 2/3 and that one's 3/2. But look, they're both negative slopes, which means they both be going down as you look at them from left to right. There's no way they can be coming together at a perpendicular line. So we would have to, once again, no. Because -2/3 is not going to work with -3/2. All right? They're not perpendicular, not parallel, perpendicular. So be careful about that. You must pay attention to those signs. It's pretty crucial. All right, lastly, this one's tough for people. We have line G that has this given equation. We want to find another equation for a line we're going to label as H that is perpendicular to line G. In other words, whatever the slope of our new line H has to be the opposite reciprocal of whatever the slope is in line G. but it also has to pass through this coordinate. If we're going to have that, that means we're going to use y minus y sub 1 equals m times x minus x sub 1, point slope form again. Now if we look right here, we notice that m equals 3, which if you were to write it as a fraction, rise over run, would be 3 over 1. So the slope of line G is 3 over 1. If we want to make a slope that's perpendicular, then we would say, well, 3 over 1 is perpendicular to negative 1 over 3. So if this is line G, this is going to have to be the slope for line H. Now I can put that value in for m. I've got my x sub 1 and y sub 1 values. I can substitute those in. And we say y minus 4 equals negative 1/3 x minus the 3. And that in and of itself is an equation. If you'd like to convert it further, you could use the distributive property, knowing that it's plus negative and plus negative. Y plus negative 4 now equals negative 1/3 x plus negative 1/3 times negative 3. A negative times a negative makes a positive, and 1/3 of 3 is 1. You now add 4 to both sides, and you have a final equation in slope-intercept form of negative 1/3 x plus 5. So we have point slope form, which was the green before I distributed, converted in 2 steps to slope-intercept form. But the biggest key is that you have to be able to steal that slope so that you can flip it and change its sign so you'll know what your new slope is. Remember, this is line G, this is line H. So those are the slopes. That was the given slope, that's the one I found because of opposite reciprocal.